Today I'm going to talk about designing data ingestion pipeline for healthcare analytics. So if you want to, I don't know, follow me on social network, you can follow me on LinkedIn, or maybe send me a connection request, and then we can, get on. Okay. So moving on to my introduction. So I'm a software engineer and consultant. So I have over 6 years of industry experience in solving business problems and driving change. So currently I work in Cotiviti Nepal Pvt Limited as a software engineer. And Cotiviti Nepal is one of the leading US healthcare analytics company. So I specialize in building enterprise data ingestion pipelines for big data analytics. And I hold master's degree with focus in data analytics, as well as bachelor's degree in computer science from London Metropolitan University. So today I'll be talking on these six related to these six topics. So today's table of contents is, first I'll be talking about a case study. So this is a hypothetical case study of a hypothetical data analytics company. So, and second one is I'll be providing overview of healthcare data. And third, I'll talk about data ingestion pipelines. What are the ins and outs? In chapter 4, I'll talk about data warehouse and data lake and the need for data lake. And in chapter 5, I'll talk about analytics. And in chapter 6, I'll just summarize whatever we discussed. So in chapter 1. So Omega, that's a hypothetical healthcare data analytics company that I came up with. So why I came up with this case study is that when we try to learn something, if we are able to relate it to something, then it will be easier for us to grasp. So that's why I came up with a hypothetical data analytics company called Omega. And let's talk about this company. So Omega is a healthcare data analytics company. Omega receives healthcare data from various healthcare and insurance companies. And let's call these companies clients for now. And Omega provides solutions to its clients. So these clients are healthcare and insurance companies. And the services include to its clients to minimize complex clinical and financial risks. The data received are related to healthcare providers, payers, and patients. So these terms may be new to you, such as providers, payers, and patients. I'll describe them in the next slide. So what is healthcare provider? So healthcare provider means primary care physicians, specialist physicians, nurse practitioners, physician assistants, and others who act to diagnose and treat patient illness and disorders in healthcare settings. And what is a payer? So payer in the healthcare industry are organizations such as health plan providers that set service rates, collect payments, process claims, and pay patient and provider claims. In other words, a payer is a person or an organization that pays for the patient's medical treatment. So the third one, what is a patient? I think everyone knows it, right? A patient is the one who receives medical treatment. So moving on. Now, Omega employs data engineers and analysts who work behind the scene to make Omega #1 among companies involved in healthcare analytics. Data engineers are responsible for architecting and implementing efficient solutions to ingest data from clients, and data analysts are responsible for manipulating, verifying, and transforming data with complex business logic and executing data standardization processes. So besides subject matter experts, Omega also employs data scientists to improve their current line of services, incorporating cutting-edge AI-driven algorithms to provide even more accurate solutions faster. So moving on. Now, I'll talk about overview of the healthcare data. So the type of data sent by the clients, those were insurance companies, right, are related to provider, payer, and patient. So here, payer is the insurance company. And I have generalized it into 4 categories. So basically, one is member data. So in member data, we have patient and provider data, enrollment data, and addresses that may be of patient, provider, or payers. So next one is medical claim data. So the data that falls in this category is billing data of hospital, physicians, and patients paid by insurance company. So third one is pharmacy data. So lab reports, prescription drugs, and others. This kind of data falls into pharmacy. So the fourth one is provider data, data related to healthcare providers, such as hospitals, physicians, patient, encounter with the physicians, and so on. So moving on. Now, all of the data that Omega receives are time-stamped flat files, that is raw delimited files with file extensions such as TXT, CSV, or DAT files. So these files are typically readable by any text editor. So what is a delimiter? So a delimiter can be either pipe or comma or tilde. So a client can send compressed files as well, such as zip, gzip, rar, or 7-zip. Some clients also send encrypted files. So if we receive encrypted files, then we need to decrypt it. Also the same for compressed files. If we receive compressed file from client, then we need to extract it. So each client uploads files to their SFTP location on a daily, weekly, or monthly basis. So this is actually a batch increment. The data is not streaming, but batch. So we receive data in batches. So moving on. The data that you're seeing right now here. So this is a synthetic data. This is not the actual data. Usually when someone shows you healthcare data, it is not actual because we are obliged to not share healthcare data. We are bound by policies such as HIPAA. So basically when you see healthcare data somewhere on the internet, those are typically synthetic data, such as mock data. So for the sake of demonstration, here I'm showing you a sample of provider data set. I extracted this one from cms.gov. So as you can see here, so this file name, there's a identifier here, right? So first is data type. What data type is this? This is of provider data type. And the file is timestamp. So here we can see it is year, month, and date. And it has hour, minutes, and seconds, and the extension. So if you see the file name here, it is provider underscore 2020-01-28. And the hour is 18 hours, 29 minutes, 12 seconds. So here HS24 means the time is in 24-hour format. MI is minutes, SS is seconds. So if you look at this data, sample data here, so you can see in the first line, that's header. Basically, each header represents a column in a database, right? So in the following rows, in the next lines, you can see the data separated by comma, right? I talked about delimited. So delimiter can be either comma or type or tilde. So moving on. So data pipelines. So what are data pipelines? So data pipelines are a set of processes that move data and transform data from various sources to a destination where new value can be derived. So in this case, our data is in SFTP location. We need to move that data into our own servers and dump into our databases, right? So data pipelines are foundation of analytics, reporting, and machine learning capabilities. Moving on. So in data pipeline, there are two types of common data pipeline patterns. Not just two types, there are many, but two are the most commonly used ones. So one is ETL and the next one is ELT. So what does ETL and ELT mean? So first, let's describe its component with the E. So what does E stand for? So E stands for extraction of data from various sources. Now T stands for transformation of raw data, which includes formatting and combining data from various sources based on business logic. Basically, we combine the data, transform the data based on our own business logic. And L stands for load. So the load state brings either the raw data in case of ELT, right? Or fully transformed data in case of ETL into the final destination. So if it were ETL, the first step will be extraction of the raw data from different sources, then transforming it, right? And then loading the transformed data into our destination. But in terms of ELT, it will be extraction of data from different data sources, and then loading it into some staging database, and then transforming it, right? So for the sake of our talk, we will use we will use ELT, design pattern. So data ingestion pattern continue. So here, what we're trying to do is, these are the Excel steps that will undergo in our process. So for extraction process, our pipeline will first extract the files from the SFTP location. This will involve in going through each client folders I described earlier, right? Each client uploads into their own SFTP location. So this is what it means. This will involve in going through each client folders and checking for files and moving the files to our server's location and logging the file and logging the transfer information into a database table. The file transfer process will involve in checking file checksum, that is the hash value of the file, to verify if the client didn't send any duplicate files. Let's say if we have a file that the client has already sent and we have logged that information in a table, I mean the hash of that file. So next time if client sends the same file, we can check the hash and identify if the file was already received, and we can just discard the file. So this will help in avoiding duplicates and preserving the file integrity as well. And once the file has been moved and the file movement information is logged into the table, a message broker, let's say in this case RabbitMQ, can then put the messages in queue and execute the file extraction load processes parallelly. So the action steps in file extraction and load processes include checking the file name pattern and file hash value, the first step. Then checking if the file is encrypted and decrypting the file. And the next step is checking if the file is compressed and then uncompressing it. So why I mentioned here, first we need to check whether the file is encrypted or not before uncompressing it, I mean extracting it, is because usually client will send files that, I mean encrypted files, those are compressed. So we cannot extract it. First we need to decrypt it, then only we can extract it. So the next will be identifying delimiters. After we have extracted the file and decrypted and extracted the files, we will see the content of the file. So while viewing the content, we need to identify the delimiters and then execute specific procedures. By procedure, I mean, for in this case, let's say I'm using Oracle server, right? So in PLSQL, there we can write different PLSQL procedures. So each procedure will act specific processes and then dump the data into the target tables. And then after the data is loaded into the target tables, we will validate record counts and produce various reports. So once data is in target servers, what next, right? So once the data is in target servers, data analysts can perform sanity checks, manipulate the data, combine it, and perform transformations and custom business logic, and execute standardization processes that will further load standardized data into the data warehouse. So moving on. So usually a data warehouse is business area specific. So by business area, I mean in terms of our hypothetical company, right, Omega. Let's say there are several departments which work on a range of services, such as verifying accuracy of payments made by payers, verifying health plans risk, and so on. So in this case, each department will have its own data warehouse. There comes a situation where one department might need access of data from another business area. So in this case, it might be a hassle always. Why it will be a hassle is because we need to get approval from the different business area people. So that would take time, right? So why is it important that we find an alternative? So the need for a centralized platform. So why we need centralized platform is to view the overall data in the organization for research and development purposes, so that if anyone wants to access it, then they don't need to go through the approval processes. So in our case, let's assume we have a data lake that's backed by Hadoop platform. So before that, what is a data lake? So let's see here. So what is a data lake? A data lake is a centralized repository, right, designed to store processes and secure large amounts of structured, semi-structured, and unstructured data. So, but in our case, right, we only have structured data because we already extracted the data from various SFTP locations and then dumped into our destination tables, right, database tables. And then finally, we dumped the transform data into our data warehouse. So what we have is a standard, structured data. So we need not to worry about unstructured, neither semi-structured. So I mentioned that our data lake is based on Hadoop, right? So let's say, what is Hadoop? So the Apache Hadoop software library is a framework that allows for distributed processing of large data, very large data sets across clusters of computers using simple programming models. So Hadoop consists of 4 modules. So as you can see here, right? The first one is Hadoop distributed file system, that is SDFS file system. So a distributed file system that runs on a standard or low-end hardware. So SDFS provides better data throughput than traditional file systems, in addition to high fault tolerance and native support of large data sets. So another one is Yarn, that is yet another resource negotiator. So what does this do? So this manages and monitors cluster nodes and resource usages. It schedules jobs and tasks. Whatever task you execute in Hadoop, it is all managed by Yarn. So the next one is MapReduce. So MapReduce is a framework that helps programs do the parallel computation on data. The map task takes an input and converts it into a data set that can be computed in key value pairs. The output of the map task is consumed by reduce tasks to aggregate output and provide the desired result. So the last one is Hadoop Common. So Hadoop Common provides common Java libraries that can be used across all modules. So this is basically a programming paradigm. So here, as you can see, there's MapReduce, right? But for faster processing in our data lake, we'll use Spark. Okay, so instead of MapReduce, we'll use Spark. So what is Spark? So Spark is much faster, but we'll need more memory because Spark processes every of its data frames in memory. So it is much faster than MapReduce. So also we'll store the data as a Parquet file. So you might stumble again, what is Parquet, right? So let's see. A Parquet file is an open source column-oriented data file format for efficient data storage and retrieval. It provides efficient data compression and encoding schemes with enhanced performance to handle complex data involved. So let's say if we extract, data from data warehouse, right, and convert it into a file that is not Parquet file, then let's say if the extracted files are in TB, then if we convert it into a Parquet file, the size will dramatically reduce to maybe in GBs. So it will save the space as well. Also, it is a column-based data set. So I'll discuss that in later. Okay. So what is column-oriented data? So typically, our source data is in relational database, right? It is in data warehouse, right? So that is rows and columns. So our source data is in relational database, and each segment of the data is based on row by row, right? So as you can see here, the data is in record 1. There is 1 row, and then another row, and then another row, right? So, but in terms of columnar data, right? So as you can see, the image right down, right? So in terms of column databases, each column is turned on its side and now represents like a row. So as you can see here, this column is now a row here. 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 So let's imagine this database, this relational database had billions of records, right? So if we convert it into a column database, then each record in the column database will have billions of records, right? So much faster query. But if we do the same query in this database, it will take lots of time. So that's the benefit of using Parquet file. So next one. So our goal, right? By our goal, I mean based on our hypothetical client Omega, right? I mean hypothetical company Omega. Our goal is to hydrate the data from source databases to the data lake. So hybrid, there's a term called hybrid, right? So what does that mean? So hybridization is a process of ingesting data into the data lake. So whenever we ingest any data into the data lake, the process is called hybridization. So what are the processes, right? So steps to be carried out. The process will be, first, we'll use Scoop that is already inbuilt in Hadoop to extract data from different sources, source database tables, based on a specific data range in batches, and dump the raw data into Parquet format in SDFS notation. Then we'll need to standardize the data to a generic format, regardless of data is standardized by specific business area. So we discussed earlier, right? So each business area has their own standardization processes. But when we bring the data into the data lake, we need to standardize again into a generic format. So for that, so to perform standardization tasks, we'll write a Spark query to create a new data frame and dump the transformed data into a Parquet file again. Then we'll need to tag the data as well to understand where it originated from, right? So, and also the ingestion date as metadata values. So this will involve in data lineage and data cataloging. So these two terms, data lineage and data cataloging, are important terms. So data lineage will help in understanding where is the data coming from and where it is going. So when you have the data in data lake, this will be really helpful. And data cataloging, another one is, so in data catalog will help in describing and summarizing the data by creating an informatic and search inventory for all data assets in the data lake. So basically by looking at the metadata values, you can find what the data is and what it is about. So next one is, we need to perform data validation and data profiling. So once data is in the data lake. And finally, we'll create Hive or Impala tables. So right now, our file is just Parquet file, right? So to view it, we either need to treat it as a Spark data frame. So for ease for everyone of us to access the file, what we need to do is maybe create a Hive or Impala tables to read Parquet files so that data analysts or data scientists can easily query the data in the data lake. So that comes handy.
Sorry for interrupt. So we have more 10 minutes. Sudipji.
Yeah, sure.
Yeah, thank you.
Okay. Okay, that was not a question, right?
We have a question, so that will be done after.
Okay, sure, got it. So the next chapter is performance analytics, right? So we have a central repository for all the data that Omega has, right? Now what? So there are several problems in the current service that Omega provides. So as Omega is a healthcare analytics company, right? So maybe the organization wants to perform advanced analytics over historical data or create a machine learning algorithm to further improve its service line, right? So let's say Omega decided to better its service regarding fraud, waste and abuse problems in healthcare, and decided to build a machine learning model to address that issue. So how would it proceed? So before going to that question, first let's describe what are fraud, waste, and abuse in healthcare. So fraud is knowingly and willingly, attempting to execute a scheme to defraud a healthcare benefit program. So example will be billing for services or supplies that weren't actually provided. Billing for non-existent prescriptions, right? Whenever someone makes insurance claims, they might present a billing document for the prescription they didn't even buy. So next one is waste. So waste is the careless overuse of healthcare services and could be done by conducting excessive office visits, writing excessive prescriptions, or ordering excessive laboratory tests, right? And the last one is abuse. So abuse includes actions that may either directly or indirectly result in unnecessary healthcare costs. So this involves payment for items or services where there is not legal entitlement to that payment and the provider has not knowingly or intentionally misrepresented facts to obtain that payment. So these are the issues, right? So how will Omega build a machine learning model to address these issues? So just like in the data ingestion pipeline, right? So in machine learning pipeline, there are also some steps. So as you can see here, the steps include data ingestion. So as our data is readily available in the data lake, we simply fetch the versioned data with a specific date range. So date range is, while ingesting the data, we timestamp each of the records in the data lake. The next one is data pre-processing. So the data that's ingested is unlikely to be ready to use in ML mode. I mean, the data is standardized, but to perform specific actions, we need to pre-process it, right? And clean the data. There might be a junk data as well, right? And we need to overcome that. So for example, this is a step in pipeline where data is tokenized, right? So features are converted to numerical values and input values are normalized, right? So in model training, after new data is ingested and pre-processed, ML model needs to be retrained and constantly evaluated. Right? Model training is the most important part. So deployment. So deploying models to production can be most challenging. Yeah, right. So because we are coming from research-oriented machine learning model, right? So to put into production in healthcare setting is a huge risk. So it needs to be tested as well. So here, not only the versioning of data is necessary, but the model also need to be versioned. Let's say we tested it, trained it on some data that was versioned XYZ, right? So the one model trained on one version of the data will not generalize in all of the outcomes. So in that case, we need to be careful. So my final is summary. So here we discussed about our hypothetical organization, Omega, right? So it's a healthcare analytics company and has data coming from different sources and has a data warehouse and data lake as well. And data engineers, data analysts, and data scientists work together to provide best service to its clients, such as healthcare, insurance companies. Also, we learned about the types of healthcare data, such as member data, medical claim data, provider data, and pharmacy data, right? So next, we talked about common pipeline patterns, ETL and ELT. And then we talked about data warehouse being business area specific and the need for data lake, a central repository of all the data, and then Hadoop in data lake, right? So how Hadoop privileged, right, in data lake, and about columnar data as well. So also the steps in machine learning pipeline. So if you have any questions, then you can ask me now. Thank you.
Thank you, Sudipji. So just we will take one question. So by Nivesh Gautam ji. So how does data engineer exactly know what data to do? Scientist or analyst needed? So do data engineer need to have machine learning and deep learning knowledge, or how does the process exactly work? So
okay.
he's trying to say more about how the system work. Yeah.
Yeah. I mean, I get the question. So basically, you want to know what the role of a data engineer is, what the role of data analyst and data scientist is, right? So that's what I infer from that question. So data engineer is the overall architect that designs data ingestion pipelines, right? So they are not directly related to the business. Need not have machine learning skills. So machine learning is typically done by data scientists, and data analysts are the ones who are directly linked to the business people. They know all the underpinnings of how the data should be, all about healthcare data, right? What the data means, how the business is, how the business functions on this data. All of the information are known to data analysts, and they perform all the data cleaning, data transformation processes based on business requirements. And data scientists, they work together hand on hand with data analysts, right, to create machine learning models. So what most of the time, what data scientists work on is synthetic data, not real data. Only data analysts have access to real data because they know the business side of it. So most of the time, they are dependent on the data scientists are dependent on data analysts. And when the model is trained, then And let's say a model was developed, right, and it was trained in the test data, synthetic data. So in that case, what they can do is the outcome of that model, they can present it as a proof of concept to the data analyst. And then after that, the final training, they will train on the real data. So in that case, data engineer, data analyst, and data scientists are separated. So yeah, so basically data scientists, they work with the data that is in the data lake, not based on each business area. So I hope I was able to answer your question.
Yeah, thank you, Sudipji, for your insightful knowledge on the topic.